Hello, 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 and welcome back. Okay, guys, so this is a continuation from the last video. Just more examples, just to show you different ways that you can do these problems. Okay, so this is page 3 in your packet 6. So number 5. Um, Pretty much the same thing that we did for number 4. Basically, I had said that if you had changed everything in terms of sine and cosine, it would have been a hot mess express. Let's hop off that ride. Okay, and let's get into doing the FOIL. Okay, so I get cosecant squared minus cotangent theta cosecant theta plus cotangent theta cosecant theta minus cotangent squared theta. I'm hoping it equals 1. Okay, now the middles drop out and we're left with just cosecant squared theta minus cotangent squared theta equal to 1. Okay, now remember, if you see something that is a trig function that's squared with a 1, we're going to go to our Pythagorean identities. So we have cosecant squared and cotangent squared. Let's see. Ooh, look at this, number 2. Okay, so cosecant squared is equal to 1 plus cotangent squared. So I am going to replace, since cosecant squared is equal to this, I'm going to replace cosecant squared with 1 plus cotangent squared. So replacing this with 1 plus cotangent squared. Then I can bring this guy down, minus cotangent squared. And then look at cotangent squared cancels out. You're just left with 1 equals 1, which is just what we wanted. Cool. Okay, number 6. So in this case, with fractions, if you're adding or subtracting fractions, there would be 2 of them. You'd need a common denominator. This is already the point where the fractions would have already been combined because it's already just one fraction. Okay, so looking at this, generally what I do for these, generally, remember, because there are no like real set rules to these, is I take the denominator, as long as there's just one term on the denominator, and I divide each of the terms on the numerators by that denominator. So it looks something like this. Tan theta over tan theta plus cotangent theta over tan theta equals cosecant squared theta. Okay, now tan theta plus tan theta divided by tan theta is 1. And now if you're not sure how this will look, what I generally do is I rewrite it as a division problem instead of a fraction. Sometimes fractions are a little bit harder to tell what to do with. Okay, and what I would do here is I'd probably turn this, actually, yeah, I'm going to turn this into 1 over tangent. Everything else the same. Okay, and then I am going to keep, change, and flip this to be 1 over tan theta. So look at this. We get 1 plus 1 times 1 is 1. And then we get tan squared on the bottom. 1 over tan squared is cotangent squared. Which, if you look at this, 1 plus cotangent squared, that's one of our Pythagorean identities. 1 plus cotangent squared, this whole thing, is cosecant squared. So this whole thing does become cosecant squared, which is what we wanted. Woohoo! That's nice. Okay, that one was a bit of a longer one. The fractions usually are. But just to recap, since there's only one term on the denominator, we divided each term on the numerator by that. Okay, tan divided by tan becomes 1. I change this into a division problem. This step, I changed cotangent into 1 over tangent. And then the next step, I did keep change flip to get 1 over tangent squared, which 1 over tangent is just cotangent. So this becomes cotangent squared. And this is a Pythagorean identity, which is just cosecant squared. And that's what we wanted. Nice. Okay, let's look at number 7. Okay, so there's a couple of things that you could do for this one. So here's what I would do, since it's kind of similar to what we just did the last one. Just to kind of keep pace, I am just going to do, since there's one term on the denominator, I am going to divide. Okay, so I'm going to separate it into secant squared theta over secant squared theta minus 1 over secant squared theta. Okay, which this just becomes 1 minus 1 over secant squared is cosine squared. Okay, and now look at this. We have trig functions that are squared with a 1. Okay, so cosine squared, sine squared. Let's see what we have here. And look at this. This is the original one. So sine squared plus cosine squared equals 1. Okay, so generally what I do, since it's equal to 1, is I'm going to replace the 1 with sine squared plus cosine squared, because that's what it's equal to. Okay. Oh, that's not what I want. So I'm replacing the 1 with sine squared plus cosine squared. And then I'm just going to bring down the minus cosine squared from above. Okay, and then condense. So cosine squared minus cosine squared. So we do end up with sine squared theta equals sine squared theta. Okay, number 8. Number 8 is going to get kind of crazy, so bear with me here. Okay, it's fraction plus a fraction, which when we have that, we need a common denominator. Okay, so when in doubt, just multiply the denominators by each other. So I'm gonna, oh, why is this green? Do a different color. Let's see, maybe I can pick a cool color. I like this lavender. Yeah, that's nice. Okay, so I'm gonna multiply this side by this denominator, so 1 plus sine theta, top and bottom. Okay, so this I get 1 plus sine theta on the top plus Now I got to multiply this side, top and bottom, by 1 minus sine theta. So plus 1 minus sine theta. Okay, because when you distribute that one, that's what you get, and it's all over 1 plus sine theta times 1 minus sine theta. Okay, so let's first focus on the top. Let's see what we can do to the top because I see some things that can happen. So I see sine minus sine, so those go away. And then 1 plus 1 is 2. So I get 2 on the top. Now on the bottom, we can FOIL. Okay, so we're going to do 1 times 1 is 1 minus sine theta plus sine theta minus sine squared theta. Okay, so now the bottoms condense. Okay, and what I end up with in the next step is 2 over 1 minus sine squared theta equals 2 secant squared theta. Now look at this. I see a 1 and I see a sine squared. So if I go to my Pythagorean identities, the 1 and the sine squared is in the first Pythagorean identity. So I'm going to replace 1, because 1 is equal to this, I'm going to replace 1 with sine squared plus cosine squared. So it's going to be 2 over, the 1 becomes sine squared plus cosine squared. I bring down the minus sine squared. Okay, and remember, we're just verifying. There's no solving. It's just making sure that the left-hand side equals the right-hand side. Okay, now let's see here. The sine squareds cancel out. We end up with 2 over cosine squared of theta, which, if cosine squared of theta is on the bottom, that means the reciprocal would be secant squared. And that checks out. Okay. Cool. Long problems, I totally understand, but we're getting through them one by one. Okay, only 2 more. So, this next one, do it in this color, that looks kind of cool. Okay, so I'm going to change everything in terms of sine and cosine. I don't know, that seems to look like the way to go. I'm not entirely sure if it is, but I'll put sine over 1 since we're multiplying it. So tangent is sine over cosine plus cosine equals secant. Okay, so if we multiply these, it becomes sine squared theta over cosine theta plus cosine theta equals secant theta. Now, I'm adding something with a fraction, so I need a common denominator. So I am going to multiply. This one has cosine, so all I have to do is multiply this top and bottom by cosine of theta. Okay, in order to get a common denominator. So I keep my sine squared because I'm not multiplying this side by anything, but on this side, I get cosine times cosine, which is cosine squared theta. These both have cosine on the bottom, so that's why I could condense the tops, and it just becomes cosine theta on the bottom. Cosecant theta. Now, sine squared plus cosine squared, that's one of our Pythagorean identities. Sine squared plus cosine squared equals 1. So I'm going to replace this numerator with 1. So 1 over cosine is just secant. Secant theta equals secant theta. And that checks out. Nice. Last one, people. Okay. Usually I say you only mess with one side. Okay. But in this case, they're both equally disturbing to look at, honestly. So we are actually going to cross multiply first before before we start this problem. So cross multiplying, multiply sine by sine, and get sine squared. And then cross multiply the other side, it's 1 plus cosine theta times 1 minus cosine theta. Okay, so this is one of those exceptions. Like there really are no rules or complete step-by-steps to these. So just take it as it comes and see how you do with them. The way I do it is not going to be the exact same way that you do it. Okay, so now from here, I would primarily work with the right-hand side now because that's the more complicated side. So I'm going to distribute equals 1 minus cosine theta plus cosine theta minus cosine squared theta. Okay, so now the cosines cancel out, minus cosine plus cosine. Okay, and we are left with sine squared equals 1 minus cosine squared of theta. Okay, there's a 1, and there's trig function squared. So I'm going to look to my Pythagorean identities. Let's see, it's going to be that first one again. I'm going to replace the 1 with sine squared plus cosine squared. So the 1 becomes sine squared plus cosine squared. Bring down the minus cosine squared. Bring down the sine squared. Okay, and then we can cancel these bad boys off. And we just end up with sine squared equals sine squared. Cool, and that checks out. Nice, so that is the end of verifying trig identities. So make sure that you guys are trying this for the homework. There is a homework due this Friday. Okay, that's for trig applications, and then this will be due next week, Tuesday, for this homework. Okay, so have a great day. Keep plugging away. We're doing it, people. We're doing it. Okay, miss you all. Bye.